Happy Monday. Did you guys have a nice weekend? It was like decent, a little bit sunny for a little while, right? Went to my nephew's half birthday party. It was at a park in Ann Arbor. It was really nice, and then the sun started setting at like 4:30, and it started getting dark. I was like, "What happened?" It's daylight savings time is the worst. Apparently, I've been pronouncing it wrong. My wife pointed it out to me. It's daylight saving time, not daylight savings time. There's no S there. Sure, but we did it. We saved daylight. We are victorious. And now it gets dark super early. It's actually better here than like the East Coast. It's even worse on the East Coast. It's just what do you do if the sun goes down at 4:30, like in dark, dark? That's so dumb. Why? Why? Okay, I don't know. We were about to cancel daylight saving time. It like had traction in Congress. I was super excited, and then it just fell flat, and I was really sad. So, but we had an extra hour, which meant my kids just got up an hour earlier than usual on Sunday. All right, so we're going to talk about the lab first, and then we'll get into the new stuff, right? So our recreate lab 5, but with classes. Okay, so let me fire up PyCharm here, and I think I need to pull. I think I had a start there that I put out in the lab. So let's see what I got here when we were working on that. Open. This menu is the worst. This is like my least favorite thing about IntelliJ. Why it does this, I don't know. OneDrive, Documents, GitHub, 1501. Did I not commit it? I didn't commit lab 6 or lab 5? What did I do with it? Oh goodness. Didn't I started in the lab, didn't I? Did I not put it in the right spot? Okay. I don't know what I did with it. We'll start a new one here. We'll do that. New project. Call this one lab 6. But it's there. Right. Apparently it's there, and it just wasn't showing me because is it my one? It's probably my OneDrive wasn't syncing right or something. This is why OneDrive is obnoxious. All right. There we go. We did have a start. Good. We got some code. So this is about as far as we got, right? We had this assignment class. Assignment would have name and points possible, right? We'd have gets and sets as appropriate, right? So we probably aren't going to set the assignment name once you have the name set. Right? Like, again, this is just a preference here. If name should change, then write a set method for it, a set function for it. If it shouldn't change, take it in your init and then don't have a set for it. Don't give them a public function to change it. And this idea, we're giving them this abstract public interface to work with, their API. Here's the things you can do. And if it's not on the list, you can't do it. Right? You got sets and gets. And then student had a name, which probably doesn't change, and then a list of assignments. Maybe you might have a name change for students, because that is something that could happen. I didn't add one. Maybe we should set one here. So we'll do a set name, given a name, right? And then self.name equals the name. So you can go change your name. This is something that happens. I didn't think about that. And then you can add an assignment, add the assignment to their list of assignments. You can get all of the assignments back out. Now, again, this is a little bit awkward here because you're giving them direct access to it. You might want to make a copy. You might not. Depends on what we're trying to do here. Right? So we just have to think through how we want people to use this. Right? Giving someone your list is a little dangerous because they can go modify it. That's all. And then gradebook had the name of the class. Oh, typo in word gradebook, really? Okay, sure. You can add a student to the list of students. You can add an assignment. So for each student, you go add that assignment, right? Because the student class has the list of assignments. Gradebook has the list of students. I mean, for every student in my list of students, I'll go and add the assignment. Then to score the assignment, I have to go through and go for every student, and then go for this particular assignment name, go find that assignment in their list and go change the score. So this one was a little bit trickier, right? So we're going to loop through for every student. Let's say for student in self students. Now I have the student, right? If I want to get their name out, I can go get their name out, or for now I need to go get that assignment, right? So now we have for assignment in student.get assignments. Yeah.
The students are in gradebook, right?
Yeah. Yeah. This is the function score assignment of gradebook. So you tell the gradebook, hey, I'd like to score project 3, or I'd like to score the midterm. And then we'll go through all the students, find that assignment, and ask for scores.
With the scoring method, shouldn't be the assigned class? The assignment.
Well, so you will actually go and set the score in the assignment here. But you tell the gradebook, hey, I want to go score the midterm. And the gradebook says, okay, here's all your students. Give me the score for each student, one at a time. Because the gradebook has all the students there. Right? So we have to go find that assignment, right? So then for each assignment in get assignments, if assignment.getName is equal to the assignment name, right? I found the right assignment. Then I can print, enter this or get an input, right? So an int score can be an int of an input. Enter the score for, and then we want to append in here the student.getName, right? Enter the score for so and so, right? Or we probably want to tell them points possible. We want to give them some information, right? Score for so and so's name, and then append in here points, total points possible is. So this is getting a little long here. That's it's a little awkward, but it'll be okay. It'll be now at the assignment dot get total points, get points possible. Right. So we'll enter the score for the student's name, and here's the points possible here. And it should prompt them for each student, right? Because we're looping through each student. Once we find the assignment with that name, then once we have it, then I can take the assignment and I can call set score to the score. Right? Or if you want, you can do all of that right in here. Right? You don't have to do it in separate lines. Separate lines are fine, but some people like doing it in one line. But that's probably a little bit more confusing. So we'll do it in two different lines, right? But you can do it in one line if you want. Right? Yeah.
Is it possible to create a list for every single student?
Well, so we're going to have all the students in the gradebook. Right? So I'm going to add all of you to the gradebook, and then I can loop through. It'll loop for every student in my students list, get all the assignments, find the one that matches the midterm, and we'll say, okay, enter the score for Eric, total points was 30. Enter the score for Jet, total points was 30. Enter the score for Vivi, total points was 30. As many students as I have in the gradebook.
Think about the students of the grades or in different classes, right?
Well, so I could have my gradebook for 1501, I could have a gradebook for 150, I could have a gradebook for whatever class I teach. So each class will have its own gradebook. Each gradebook has its own set of students, and each student has its own set of assignments. It's like when we had the dictionaries. We had a single dictionary for your gradebook. The dictionary had a key of the student name and the associated values on other dictionary of assignments with a key of here's the assignment name and the associated value of points possible and score. So instead of using dictionary and dictionary and dictionary, we're going to have a class. The class has a bunch of other classes, a bunch of students, and students have a bunch of assignments. So we don't have to use these key and value pairs. We just have instances of our classes
And so all these information is in the same class. Why do you have three different classes?
because they're different, right? So assignment just knows about assignment things. The city, we were taking all the details around the assignment now, right? Its points possible, the name of the assignment, right? That's one nice little noun that we can encapsulate into one little detail, right? Otherwise, our student would have to have a dictionary of assignment names and key and values, right? We could, but using classes, using an instance of assignment lets me not have to do key and value pairs everywhere, right? I can use my public functions, and then I can do things like not let you change the name of the assignment. Once it's the midterm, or once I said it's worth 30 points possible, you don't have a way to change that. With a key value pair in dictionaries, you can go change the points possible anytime you want, right? Nothing stops you from doing that. So it adds a little protection around this encapsulated package. Right? That's the other added benefit of this object-oriented programming. We're making sure that things fit the rules that we say. When we did the vehicles, right? You can't drive if you don't have enough electricity in the battery. We can make sure that the code we write reflects the rules that we want to apply. If you just have key value pairs in a dictionary and you say, hey, I want to, have a function for drive, it's going to go do it. Right? There's no way to prevent that from happening or prevent that from being modified. So the class adds this protection around what we're doing with all of our data. Um, so adding a student, we didn't copy assignments yet from another student. We have to do that. So before we go and add the student, so if there is another student, so if the length of self.students is not 0, or really like if the length, right? Remember Python's truthy, you might just say if length, because if it's 0, nothing happens. It's false. Right? False if length is 0. So if it's not 0, then I know I need to go and copy all the assignments. I need to get all the assignments to make copies for the students here. Actually, I guess I have to do that after, don't I? So I can't even use that trick. So we'll add the student, and then we'll say, hey, if the length is equal to 1, or is not 1, right? Does not equal 1. Because if it is 1, right, if it's 1, it's the first student, and there's nothing to copy. If it's not 1, then I have to go copy, right? Then I can take my student to copy, can be my self self.students at index 0. We'll just take the first one, right? And then I need to loop through. So for assignment copy in students copy get assignments, right? We can go and loop through. Now I'll get each assignment out, and I have the new student I've added, right? So that new student I've added, I can say student dot add assignment, given the assignment to copy. Now the problem here though is it's going to keep all the original scores. So I don't actually want to hand it the assignment to copy, right? Because this other student might have already been scored. They might have a score. I don't want their score. So I'm going to make a new assignment here. So I don't know, copy equals an assignment. And the assignment init here wants the name and the points possible. So I'll give it the assignment to copy dot get name, and I'll give it the assignment to copy dot get points possible. So sometimes the type ahead, the IntelliSense, doesn't work very well because it doesn't know what type it's supposed to be here. It's a little bit annoying sometimes, right? This way it makes a new assignment to avoid getting a copy of the score, right? To make the new assignment so we don't get the score, go and add it in, right? So that's how I can add new students and get copies of assignments this way. I can add assignments to every student. I can score assignments for every student. I can get students. I get some gradebook here, right? So if my choice is add a student, enter the student's name, and then take my gradebook, CIS 1501 dot add student, given, now I need to make a new student, right? So that is, student needs just a name. So I'll say this is the student init here, given name, right? Or I can do that as 2 lines, like the new student, right? You can say new student equals student, given the name. However you want to nest those is fine. Right? If the option is add assignment, we need the assignment name, we need the points possible. We'll make the assignment and we'll call add assignment. Right? And then for score, right? Else if the choice is score assignment, score assignment. Should make this all lowercase, I guess, right? So we'll take choice dot lower. There we go. Make that lowercase. So if it's score assignment, we need the assignment name, right? Enter the assignment name. And then call grade CIS 1501 dot score assignment given the assignment name. That'll go through and do all the prompts, right? This will go out and print all their details. We can print all that later when we want to, but right? I think that's what we're working on. So this would be sort of a loop then, right? So while choice does not equal quit or something, we should prompt. And I'm going to put the prompt at the bottom here for quit. And then we'll just say this equals, how about that? Oops. So empty is not quit. So it's not this, it's not this, it's not this. So it'll prompt, and then it'll come back to the top. Just doing our little loop. So I can add students, I can add assignments, I can score assignments, right? Should we give it a try? All right, so we probably want to add a student first. So add student. Let's add Eric. Okay. Do you want to add an assignment? Okay. This is, how about midterm was 30 points. And then let's go add a student. Let's add Jeb. It should give given him a copy of midterm. So now if I score assignment, I say midterm. Oops, I spelled that wrong. Score assignment. There we go. If I just want to score the midterm. Oh, goodness. Uh-oh, we're close. Oh, I can't concatenate an int. Yep. When I try to concatenate here, the get points possible, we have to tell Python this is a string, please, because it was not in a print. When using an input, it's very particular. In prints, it knows to change them into strings for you automatically. And we were getting close, though, right? We were getting close. Let's try it again. All right, add students, Eric. Oh, goodness, that was funny. Add assignment, midterm for 30 points, add student for Jeb, and then score assignment for the midterm. There we go. All right, so enter the points for Eric. Points possible was 30. Eric got 30 out of 30. Jeb, he didn't study much. He got 25 out of 30. We'll quit. And then our loop here says for every student, print the student name. For every assignment, print the assignment and the assignment's name. Oh, we forgot their score. Shoot. Comma, score, assignment.get score, assignment get score out of assignment.get points possible. I have to type it all in again. Oh dear. Let's try one more time. Add student, Eric, add assignment, midterm, 30 points, add student, Jeb, score assignment, midterm, 30 points for Eric, 25 points for Jeb. Quit. There we go. So we get Eric has the midterm 30 out of 30, Jeb has the midterm 25 out of 30. Looking okay so far. So we're using classes here. So we have the public functions instead of a key and value that's dictionary, dictionary of dictionaries of dictionaries, messy nesting. This is still a little weird, right? Because each of these things has lists, it has more lists and has more lists. Uh, but hopefully this is a little bit cleaner than doing these key value pair sort of things. And again, it adds that protection in to make sure that I can't go change things that I shouldn't change. Yeah.
You'll that students use in one file.
Hmm.
Their assignments in other
Yep.
files, their grades on.
So their score is part of assignment. So in assignment, right, it has your score on that assignment, what your score was and what how many points possible it was. Because if we when we think about making classes, you want to think about nouns and the attributes of those nouns. So like assignment's a noun, the attributes, things that we know about assignments. Its points, how many points you got on it, maybe these sorts of things. So each of you has your own separate midterm, right? You don't want to share one midterm score. Well, maybe you do, maybe you don't. But each of you gets your own set of your score here. Now we've copied points possible. It's not the end of the world here. But as we make more assignments for every lab, we'll have lab assignments. For every project, we'll have project assignments. And we'll make more and more and more of these assignments. And you just have a list of them for yours as you as a student. You have your list of assignments that include your score.
How do you connect the different students to the different assignments to their different grades?
So their grade is part of assignment. So your score is your grade. So assignment is both your score on it and how many points possible it was. So that's how it's connected. So when I add that assignment for you, it's now connected to you because I added it to your instance of student. Because each student has their own list of assignments, their own copy here of assignments that they would go through. So here, let me put it in debug mode. Maybe that'll be easier to see. So let's do for a little breakpoint in here. All right. Let's just continue for now. Oh, hang on. Sorry, continue. That one. There we go. So let's add student, Eric, and then continue again. Add assignment, midterm, 30 points possible. Continue. All right. So in here, then, right, if I look at my variables, oh, I gotta wait till it pauses again here. Let's do add student, add Jeb. All right. So in here now, I have the gradebook instance. So the instance of gradebook I call CIS 1501 has the class name and its list of students. Right? This list of students now has two students. It has Eric with an assignment of midterm and 30 points possible. My score is currently 0. And then the other student in the list here is Jeb Jeb has one assignment in his list. It's the midterm with 30 points possible. His score is currently 0 because we haven't scored it yet. So each student has their list of assignments here, and that's where their score is as well for it. It's associated with that assignment, that the number of points possible. So as I go add more assignments, right? If I want to add more assignments here, let's do continue add assignments. Let's add a final project for 40 points here. Right now, I should have more assignments in this list here. Right, I've got midterm, and then I have final project for 40 and 30 for the student of Eric. Right, and then for Jeb, right, he's got now another assignment here. He's got the final project for 40. His score is currently 0 for Jeb. So as I add assignments, it adds it for each student in my list. And when I go and score it, it will ask for the score of each one. And we'll go assign a score to each one of these things here.
Also, could you please describe the function of each class here?
So the grade book has the name of the class and my students. It's all grade book needs to know, right? So grade book, right? Those are the attributes that it has. So each grade book can have a different name and a different set of students, right? So I'll have a different grade book for every class. But the way I interact with gradebook, I added more public functions because there's more things I do with my gradebook, right? I can add students to my gradebook. I can add assignments to the gradebook, right? Because when I add an assignment, I want to add it for all of my students. So I'm putting this at the gradebook class because that's what I'm interacting with. Like, hey, here's a new assignment for this class. Let's add it to the gradebook, right? When I want to score an assignment, I go to my gradebook and say, hey, let's score the midterm.
So the grade book has each has both the students and the assignments, right?
Well, it has all the students, and each student has all their assignments.
Okay.
Yep. Yeah, so they're all like nested inside of that, right? All the assignments are inside a student. All the students are inside a gradebook, like those nesting eggs, the nesting dolls.
That's the grade book class.
Yeah.
But what about the assignment for the students one?
So then students just have a name and then their list of assignments. And then they give you a way to add an assignment here and the way to get the assignments out. So student says, okay, if you want to add an assignment to my list of assignments, great. You want to get my name, set my name, or get my list of assignments. So that's all student is. It's just your name and then your list of assignments. We could add more details if I wanted to. I could say like have a list for attendance or something like that, and maybe I put that in my gradebook. I might have participation point. Anything I wanted to add would be attributes of student that each individual student gets here, right?
The thing is, where go the students to the grade book class?
Mhm.
Why don't he plays in class?
Because that's the list that Gradebook has. Gradebook has students. So Gradebook uses this class for student. Yes.
So I was kind of confused with that too, but no, the yellow the list of seats. Things that this aren't just like strings, there is classes in that list. Oh.
So I'm using this class in that list.
So grade the class grade book use the class student.
Yes. And the class student uses the class assignment. So what it puts in the list is instances of the assignment class here. It's a very different way to think of things once we start putting objects inside of objects inside of objects. It's kind of weird. Ideally, this makes more sense than dictionaries and dictionaries and dictionaries and dictionaries. It should eventually, even if it doesn't today. Because like we understand key value pairs, but that just doesn't scale well. Imagine now we wanted to take this to the university level. Like the university registrar has all of the students somewhere. It has all the classes you've ever taken. It has all the list of degrees. It has what classes you have to take for what degree. Like, do we just have 50 different dictionaries nested in each other? Or like, do we have a class for that? Like we might have a class for here's the degree for data science. That class would have a list of classes that you have to take to pass that to get that degree, right? And then your student class might have a list of classes you've passed or like what grade you've gotten in each of them. And I can take this list of classes compared to the student's list of classes they passed and see if they match or see where your gap is and say, hey, you still need to take these classes. By the way, you should register for winter soon. Here's a list of classes you still need. Like we put these attributes together so we can work with them and not have dictionaries and dictionaries and dictionaries and dictionaries and dictionaries. We haven't done anything we can't do without classes, but it's a way for us to talk about code and think about code and add some of those protections to our code too, like making sure you can't drive more than electricity that you have. That is harder to do if you just have a dictionary, right? So we're able to do more things, do them a little bit nicer, I suppose, right?
So the class gradebook, which is looking for the class gradebook has both the students and their grades, right? So the class gradebook uses the class students,
Hmm.
which stores the students' names, and students class uses the assignments.
Yep. Yeah.
And how do you adapt the student class assignments within the class student?
So student just has this list, so I can add an assignment, which adds to my list, or gets the list back out. So get assignments just gives you the list of assignments, or add assignment adds an assignment to the list of assignments. So I'm just saying there's no set assignments. It's an add assignment or get assignment because I'm not going to say give me a list of assignments here. You just add one at a time or get the entire list back out. That was just this is the way we chose to write it.
But somewhere in the code, you have to instance
Yeah. So when I
student class, right?
yes when I add a student here, I create an instance of student. So that makes a new student. So new student equals the student init method here, and I give it the name. I can add the new student here. I was just doing it on one line. Two, right? This calls the student init method, makes an instance of student. I called a new student. I'm going to call the add student method of gradebook, which says, hey, let's go add the student to my students list. And then, by the way, do I need to copy some assignments out? Right? This copy part was obnoxious when you had the dictionaries, right? Because you had to see was there anything else to copy and go through and grab all those key value pairs and do all that stuff. So similar idea. We're going and adding all those.
Check out in the house, okay.
Awesome. Yeah, it's fun. There's a lot to it for sure. All right. The super caffeinated coffee at the gas station apparently spikes my blood sugar more than regular coffee. Caffeine can do that. It's super fun with diabetes. Super fun. Uh, but this is good. This is I got both mugs today. Forgot to fill up the thermos at home before I left. My sleep schedule's been so bad lately. I don't know about you folks. It's just so bad. Was up till like 4 in the morning, and then got up at 8, did some stuff, and then went back to bed for an hour, and then got back up and left for class. Uh, all right. Anyway, yeah, next semester we're all afternoon, which is nice. The lab's a little earlier, right? We start lab at 12, but then our class is at 2. That's pretty handy. All right, cool. So that was the lab. So moving on then to new stuff, we're going to talk about exceptions. Exceptions are phenomenal. Let me turn on these labs here while we're here. So when we were doing the little car example, we had that our function for drive that returned a true or false. Or like, if you could drive that far, we would return a true and add to your odometer, do those things. Otherwise, we return a false. Does that ring bells? So that's all well and good here, but the idea with the class, right, is that it's independent of whatever is going to use it. That's the other benefit of writing classes, right? It could be used in a mobile application, it could be used in a web application, it could be used on my phone or my NumWorks calculator, right? Those cool calculators that run Python. That's the coolest thing I've ever seen. I love it. Super excited. Did I show you those? I didn't show you those? Works calculator. I don't get paid, by the way, by NumWorks. It's a graphing calculator that has a Python shell. You can run Python on your calculator. And they're cheaper than the TI calculators, which they've had TI 84 since I was a kid, and they're still the same freaking price. Like you can buy a phone for cheaper than a TI 83 calculator, TI 84 calculator. Which of those does more things? Right? They've got this ridiculous monopoly. So I'm super excited to see another person do it here. And then they've got uh, they've yeah, try it. Try it online. They've got their little emulator online. Like you can like click through and do the stuff here. Like, hey, I want to go do. How do we go down? Let's go to Python. Python shell. How do I get to, there's Python shell, right? Now, again, this is not friendly to work with, but you can program in Python code on your calculator. It's amazing. It's so cool. Anyway, um, so exceptions. That's the way that our classes communicate with other classes. So if we are independent of however it's being used here, right, just returning a true or false doesn't mean anybody did anything with it, right? Like if they wrote a program using our vehicle class and they're like, hey, user, how far do you want to drive? And the user said, I want to drive 10,000 kilometers because I'm going to drive around the world. Kilometers. Seriously? All right, 40,000. All right, so 10,000 gets me a quarter of the way around the world. So if I said 40,000 kilometers, we'd return false and tell them that it didn't work. But I have no idea if the program that tried to do that actually did anything and told the user it didn't work, right? Like, let's go back to our class here. So that was our recent projects, chapter 9 classes. Right. So we had this electric car, right? So when we tried to drive, like we did our own little fake testing here, I could just say, get a int of an input of many km you want to drive, and I'll take Eric's car dot drive this number here. Sorry, let me zoom that in a little bit. Right? Sure. They didn't do anything to that result. I never stored the if true or false, or they just told it drive. Right? I don't know what's happening here. So I tried to return a true or false, but and I don't know if they did anything with it. So a more forceful way of making someone deal with bad stuff is an exception. And we've ran into exceptions before. We've done exceptions, right? If I said, some list equals a list, and I wanted to print some list index of 1, right? What do we get? We get index error, list index out of range. This is an exception. My program crashed on me. We get to do this to other people now. Super excited. We get to make our program crash so that they have to either deal with it or crash. Because if this is going to put us in a bad state and that's not allowed because the rest of my program will suck, we'll make them crash or deal with it. It's like, imagine automatic flight control in a plane. And the pilot's like, no, I want to go down 10,000 feet. And the plane is like, you're at 5,000 feet. You can't go down 10,000 feet. Do we want to just return a false and let them try it anyway? Or do we want to be forceful about this and say, no, hard stop. Don't do this thing. So we can go and add exceptions. So in our class here, let me shrink this down. Where's I think I zoomed in a little too much here. Sorry. So drive. So instead of just returning true or returning false, when I get to here, instead of returning false, I can raise an exception. So I'll be very forceful. I'll say raise what is it here? Error. So there's all sorts of interesting errors that are built into the Python library. I think probably value error is probably the best one here. And then I can give it a message if I want, not enough charge to drive that far. Okay. Now when I run my program, how many km do I want to drive? A bunch of kilometers. We get a crash. We get a value error. And we get the message back out here. Not enough charge to drive that far. And we get the stack trace, just like we did when we got an index out of bounds. It says, hey, at line 25, something screwed up. All right, well, what's line 25? Line 25 is right here. We raised the value error. How did we get here? We got there from line 146. Okay, line 146 is when I called drive. Right? We get these errors back out. So you can force someone to deal with this issue, right? So this is a better way for classes to communicate when really bad things have happened. Now, if we don't need to crash the program because a bad thing happened, if just returning true and false is okay, that's a decision we get to make when we make our software. We don't have to make things crash, but if we want to be forceful, that's the way that we can communicate back to whoever called our code. Say, nope, you did a bad thing. Not allowed. Right? Like when we tried to the odometer, we had an odometer, right? We never had a set odometer, right? We just had drive. Yeah. So we might also have, or not a charge. I guess this could be less than 0 too. We have some other errors. Maybe if we were trying to charge, if someone said, hey, I want to charge 50 gazillion kilowatts, that would probably blow up our battery and do a bad thing. We could raise an exception if we want, right? Chargers are smarter than that. There's all sorts of other cool electronics that go into charging, but that sort of idea, right? We can add in these sorts of protections here. Rather than just a return true or false, we can force errors. Now, to deal with errors is another thing. So this is something we've not been able to do before. When we ask people for input here, like this, hey, how many kilometers do you want to drive? And I say 10, TEN, it crashes the value error, right? Invalid literal for int with base 10, 10. Python doesn't know what to do with this, right? When we told it to make it an int, it doesn't know what to do. And we've not been able to solve this so far. So everything up to this point is that your user will probably give you the right thing. And if they don't, it crashes, that's on them. I don't know about you, but it's really frustrating when apps crash on me. For some reason, probably because I know better about how to write software. Like when stuff on my phone crashes, it's just so irritating. Like, and I get mad at the developers. Like, do better. Come on, do better. So, sure, let's do better. So, if we know something might raise an exception, we can do something called a try block, where we tell Python, "Hey, I'm going to try something here," and then if there's an exception, so try, and then if there's an exception, we can do something here. So we'll say we'll accept on this.
What's the try?
So try says I'm about to do something that might raise an exception. Please try. So it sets it up so that it can catch these exceptions and not crash. So we'll say accept E. I think or as E. Is that what we do?
Well,
Yes.
set out an error, we go to the try and then we X out.
So if an exception happens, we'll catch it in this accept block. Yep. So we can do value error, right? Value error. My goodness, I have to go to the Zybooks. I don't remember the syntax here. Why do I not remember? Just accept. I want the error. Come on. Accept. Okay, type. There it is. There it is. Okay, so accept value error. I think that's what I want. So if I get a value error out, we can do something specific. Now, this lets me save the error so I can get some messages out. So I can print e dot, or I'll just print e here. Otherwise, we just kind of, it swallows it here. So we can get a, I don't know, while. Now, I don't love while true loops, but you can sort of do a while true here and then break. This is a little ugly. We'll get some other ways to do these here. So if an exception happens, the code stops immediately at that line. So if an exception is raised, we never get to line 149. If an exception is not raised, then we get to line 149, my loop stops. Right? So let's give it a try here. So this one is only going to catch a value error. Do we have, is this one a value error too? I'm trying to remember. I think it did a value error here, right? For car. Yeah, we raised a value error. So we can catch both value errors here. I think there's another one we could use here. Error. We have. There's got to be a good one here. Uh, Look at all these different kinds of errors.
Is there actual difference between these errors?
Sort of. You're supposed to use the right one because you can catch them specifically. I think value error is fine here because it's a bad value essentially. There's a bunch of different kinds here. You will look. You can even make your own custom errors, which is really fun. You can have your own set of errors. Let's give this in debug here. So we're going to try to get this out here. So it's going to say how many kilometers do you want to drive. So if I say 10, now I can step here. Oh goodness, I don't want that code. I wanted to step into my code. Hang on, sorry. I need to step into mine. I don't want the parser py. Okay. Let's resume. 10, step into my code. Really? Oh, I'm sorry. It did. It did it. I didn't notice the output. So it said, hey, invalid literal for int with base 10, 10. So when you print the exception, that's the message we were getting. It's not the whole bit of red stuff. Remember before we were getting like, it crashed to this line, it crashed to this line. If you're telling your user a bad thing happened, you probably don't want to tell them at this line of code something bad happened because they're not going to care, right? They just want to know what the problem was. So now I get to try it again. So now I can give it, let's do 100,000 million here, right? So now we're in our code here. So let's step over, we raise another value error, and we go to the catch exception here. So we got our error, not enough charge to drive that far was our exception. We're going to print that out. We go back to while true, Eric's car drive. Not enough charge to drive that far. So we can use these exceptions with try and catch here to make sure we're getting good input. This was the only way to do this with integer inputs. It would only give us a value error. We had no other way of doing that. For the vehicle, right, we had the option, maybe we were doing this in a loop while it was not true because we could get the result back out. Didn't have to be an exception, but exceptions are good. That's the way the class communicates that an exceptional thing happened. A bad thing happened. Yeah.
If it, you accept like all errors.
Mm-hmm. So if you just take out this value error as E, you get all exceptions. But now, can I do as E? I don't know if I can do as E. I think exception as E or error. I think it might be error. Maybe it's exception. One of these catches all of them here as E. E. I think it's this one. Let's give it a try. 10, yeah, millions here. So we haven't gotten to this yet, have we? Hang on. No, we haven't got to this yet. So this idea of inheritance, when we get to that, will make this make more sense. So any error, value error, other sorts of things are exceptions. So catching an exception catches everything because they're all exceptions. Don't worry too much about it. It'll make more sense in a couple weeks. Yeah.
If we are creating an exception at any point, that's because we know that the code is going to break by the fault thread.
So we use a try because we know it could raise an exception and we'd like to not crash. So that the try block says this might crash. Give me a chance to not crash if a bad thing happens. Like then we can do something with it in this except block, whatever happens to be. So it keeps it from crashing. So like their example here was fine. Like they have a little BMI calculator here. Getting your height and getting your weight calculates your BMI. This could crash, right? If you give a bad input, then it crashes on you, right? So with a try and accept, their example here is okay, could not calculate, enter any key or Q to quit. If it's not a Q, they want to try again and let them enter it again. So it's going to loop for them while they've not told me they want to stop. All that happens in the exception is we tell them it didn't work. We didn't tell them why.
The trial is a thing I actually want to go to the accept is case breaks.
Yep.
The accept.
Yep. Yeah. So if it crashes, jump here, please, instead of ending the program. Like come here, run this code instead of crashing. In our case, we're just going to print the exception and we're just going to keep on going. We're going to keep letting the user try and drive.
We like if everything's okay, do this, else is the accept.
Yeah. Yeah. And we could drive a bunch of times, right? You could call drive 3 or 4, 5 times. If at any point it throws an exception, the rest stop running, right? So the first time that an exception happens in a try block, the rest of the code is skipped because it goes from the exception right to the catch to this handler. So if my first drive works, my second drive works, but my third drive I give it something invalid, it will jump to the accept block. If on my second one I give it something invalid, it'll jump to the accept block and skip the third one because it says, "Oh, I can't continue. A bad thing happened. I have to jump to the accept block." So we don't always want to make them. You could like have one try block for your entire program. That's probably too large because you want to be very specific around what thing happened badly, so I can fix that one thing rather than I'm going to try my entire program here. If at any point I get bad input, do I just start over? I mean, you could, I guess, but that's not very friendly. Like in our gradebook, if at any point I got an exception, I could start back at the top. They'd have a brand new gradebook again then, like completely empty. They'd have to add more students. They'd have to add more assignments just because they typoed a number when they're doing points possible. Right. So like try and accept on just that points possible section is the better place to put that. And I can just try that again. Okay. Hey, I couldn't understand that. You didn't give me a good number. Try again.
So
That sort of thing.
Accept statement as a pointed to the number.
Yeah. So try and accept. Other languages call it catch. So I say catch a lot. I'm sorry. Accept is a little weird, but try and catch the exception, handle the exception, deal with the exception. If there's an exception, do this instead, sort of thing here. So common one, end of file inputs we might have seen. I think you see those a lot in your Xylabs. If you are trying to read too much input, to have too many inputs, like, oh, end of file. Key error, if we don't have it here, divide by zero errors, value errors are really common. Index errors we've seen a lot before. There's a lot of exceptions. Handling multiple is interesting and all, but not all that important right now. So there's like, hey, you might have a value error or you might have a zero division error. Two different things. We can be very specific around what went wrong here. Is fine. Um, so in our own code, raising exceptions is phenomenal. And instead of so printing errors is the worst, right? We don't want classes to print anything basically ever, unless that class is specifically designed for input and output, because we want that class to be portable. The class should work if it's a web app or a mobile app or a desktop app or a graphical user interface app. If you print to the screen, no one sees this message, or there's no guarantee they're going to see the message, right? So classes should use exceptions instead of printing. Just printing an error is no good. We have to communicate that a bad thing happened. So you can raise your error, and then they have to do something with it. It's a little bit nicer, right? That's this idea with functions, right? Our functions can have these exceptions here, and that's what we're doing with our classes. Bad things can happen in there. Um, a last thing you can do, you can have an optional finally block. So finally will run at the end, no matter if it worked or we raised an exception. So a lot of times when you deal with files, like you want to make sure you close the file when you're done so it doesn't stay open. If the file's already open, you try and read it again, weird things happen. So generally with files, we'll close the files out. So if we do want to try and reopen it, we'll try it again, and it's not already open in a bad state. So this will run even if the try works, and it will run after the accepts if an exception happens. So no matter what, it finally will run when this block is done. You'll get this finally code here, which is pretty good. Um, we haven't got to file input and output, so that's not very interesting yet to see what it's doing. Yeah.
Let's see, didn't put a file there, usually finding that correctly. Like, just that block goes after all the accepts, wouldn't it be the same thing?
Yeah, there's no loop in this one. So I would imagine there'd be a loop somewhere in here that's trying to keep that file open. They just don't have that portion showing here. Yeah. So we print result as Z, either it was -1 or we actually set Z, right? We got options. This custom exception type, again, we haven't got to inheritance yet, so it doesn't make a lot of sense, but you can make your own exceptions if you want to have fun with it. And like it can be your own specific class for exceptions so people can catch just or to handle just that exception type rather than the broad handling all exceptions. Uh, yeah. And then modules, we sort of started modules a very tiny little bit already. Modules are just files, right? I have a main module and I have a test main module. They're just Python files, right? Each Python file you can run and it does its thing. So you build out modules to make libraries of code. That's like when we import math or random, right? There was the random file. We imported that random module, the random file, and we got all the functions out of it. So when you get to an import line, Python basically says, go find this file and stick it at the top. Imagine as if you were to read this file first, if I were to just copy paste the contents in here. That's essentially what it's doing for us. It's pretty cool. So it lets us use other code that's already written in our class, in our files. And then you can organize things with modules if you want. So they have functions, they have script one, they have script two that use the same set of functions. Right? Once you've defined the function, you want to be able to use it. That's one of the reasons why we write functions. You don't have to write the same code twice and feel bad about yourself. It'd be nice if you could use it in multiple files without having to copy paste. Well, the right way to do that is to make a module out of it. So you can do those sorts of things. You can add them in. You can import them that way. Um, when Python looks for modules, it's going to try and find one in the directory where your script is running. So if I want to import main, it's going to look for a file called main in this folder where it's running. If it doesn't find it there, then it'll go look in anywhere that's my Python path on my computer. It's generally, you can say, hey, here's where Python is, and then it'll go look where Python's installed and find some modules. So if you make your own module named random, you can do some weird things, right? So if I want to, let me start a new project here. So this is week 11, right? Are we 11? 10? My goodness. I think this is 11, right? Did I number the weeks? I think I numbered the weeks. I didn't number the weeks. Shoot. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It is week 11. I was right. Week 11. Sections and modules. So I'm going to go add a new Python file. I'm going to call this one random. I'm going to define ran int given a and b, and we're going to return 42, right? So if we wanted to import random, and then we want to print random.randint 1 to 10, what do you think we're going to get? We're going to get a number 1 to 10, or we're going to get 42? We got 42, right? Because it follows that sequence. It says, hey, I'm going to look in the directory you're in first. So you can do some weird stuff to Python by adding in modules that are named the same as the built-in system modules. I don't advise that. Weird stuff will happen, right? Like you don't want 42 every time, but you can, right? So if I drop in my module here, it's going to screw things up in a program that's supposed to use random numbers. Yeah.
All know the actual names of these modules.
I just know this one because we've used it. You can go to the Python install like and see where all the Python modules are. There's lists online and stuff, or you can just go look on your computer. Yeah, but it's whatever we name it. It's just the name of the file.
Well, here, where are you recording the module record that you created instead of the actual built-in random file?
So I added the file to my project here, so it's in the same directory. So in this folder, I have for week 11 exceptions module, I have two files. I have main py and random py. So they're in the same folder. So when I go and import random, Python says, oh, let me go find one that's in your directory. You probably want the module that you wrote in your directory. In this case, I did a dumb thing on purpose, right? I wrote random when I should not have redone my random one. Right? I really want random, but I didn't get it because now I got my module instead of the Python install version of random. So it gets a little weird, but you can. You saw in the test cases it used this from notation. So this is just a shortcut. If you only want certain functions out or certain classes out, you can specify only those, and then it saves you a little bit of typing. So when we did our recent project, Lab 4 with classes, right? I think it was this one.
We said, why do we work with names circles? It's a like collections in both names circles, right?
Yeah.
Where's this collection?
So collections is the module in the Python library. There's the Python's.
The name circle collide with the thing, right?
Yeah. So collections is here's the module. It has all these things inside of it. These are part of the collections module in Python. Yeah, so that using that shortcut here, so I think, oh, we didn't put it in a different module. That's right. So I could put connect for in another module here. We pull all this bit out here. Let's go add a new Python file. We'll call it connect for. So if I want to use connect for, then I can say import connect for, import that module. But now it doesn't know what connect for is because I have to say module name dot class name. Oops, that should have been lowercase. Rename that. Refactor rename. Sorry. Connect for. Module should be lowercase. Sorry. My bad. But that's kind of annoying to have to say connect for module.connect for class. So if you want to save time, you can say from the connect for module, import the connect for class. Then you're telling your script here, hey, I can just use this directly because I know it's coming from this module here. It saves you typing the module name. That's all it does. So we saw with like our unit testing when we did classes here, we were importing from unit test, import test case. So we could just say test case instead of unit test.test case. Saves us a little bit of typing, right? It also, I believe, it's faster on your import because it doesn't import the entire file. Test case does a whole lot of, or a unit test does a whole lot of stuff. I only want the test case piece of it. So it limits what I'm importing as well, which is nice. So if I were to, let's go back to our random one here.
Otherwise, sometimes use the bubble thing.
Yeah, yeah. So I could say, hey, from random, import randint, and then I could just say randint, 1 to 10, right? That's kind of nice. Let's go back to random. Let's do fine fake random, A and B, turn 42. So if I just import, um, let's import all of random. So we'll import random, and we have random.randint 42. We get 42. But if I say from random, import fake random, now it doesn't know what this is, right? Because we didn't import that. It doesn't belong. We only imported the fake random function. So you can import specific functions, specific classes, rather than the entire file at a time. Why? Read it. There we go. Oh, that's weird without that project view. Right. So you can be specific about which ones you want when you import with modules. The other piece here is when you import a module, because it's basically reading that file. Let's go back to our chapter 9 with classes here. We wrote a bunch of junk here with Eric's car, and it did a bunch of stuff. So when I run my test cases, when I say import main, it reads main and does main, and we get a bunch of garbage output, right? Including a bunch of inputs. Like, hey, now it's waiting. It can't even run the tests because it's waiting for input here, right? Uh-oh, and we crashed. So it runs everything. So if you don't want code to run when you import it, you can hide it. And the way to do that is you put it inside of this. If under underscore name equals under main. You might have seen this, I think, in the starter code. When you make new projects, it gives you this as the starter code, I think. This prevents this code from running unless this module was the file ran, not imported. So when you import this module, the name is not main because it's being imported. It's not the main module. If you run this module, this file here, main, then name is main and this code will run. So I can run this code here, and now it runs, right, 10, 10, 10, and we crash. But over in test main, when I run my test net, when I import main, this is the main file that I'm running here. My tests go. Oh, now our test is failing, right, because we have an exception, but we haven't got there yet. The rest of it doesn't run because its name is not main.
So when you import main, house the one main, and you label main equals prevents the module we're importing from running.
It won't run this code when you import this module. So you can have code that runs when you run it, not when you import it. So when I was importing main, it was running this code because it was here in the file, right? When you import it, it reads the file, basically copy pastes it at the top. Yeah.
So does that check if the name of the file is made instead of checking like you're running this file?
It checks if you're running this file. Yeah, it's confusing because we name our script main.
Yeah.
Sorry, that's a little bit weird there. So if we go back to exceptions and modules here, we might have random py, right? Maybe I have a print random file, right? If I import random, I get the random file, right? Because we've copy pasted essentially. When I say import random, it copy pastes the random file, the random module on top, right? But if I check, if I say, hey, if name is equal to main, then do this thing. Oops. One more. There we go. Now when I import the file, it doesn't run. But if I run random py, it does run. So it lets you have code that runs when you run that module, but not run when you import it. Again, it's a little weird to mix and match because generally when we start writing modules, we don't put code in them that runs. We only have the functions of the classes. But you can put stuff in here if you want. Like if you're trying it out yourself just to see what happens, you can go and hide it there. Yeah.
So why don't you the title
For where?
for yeah.
So double underscores in Python mean it's a super special secret keyword. It's literally what it is. So there are some things that have double underscores. Like there's just some things.
But I'm kind of hooked. The
So main here is a string. So the name of the file. I'm sorry. This name here gets set when you call Python. It sets some variables behind the scenes. We haven't really gotten into the depths of interesting stuff that happens. And it's main if that is the main module you're running. It's not main if it's not. So I think we can see from here. Let's put a breakpoint. I think we can run that in debug mode. Did debug shoot? Let's do debug here. Debug. Okay, so we're about to import randoms. So step into our code. It didn't do it. Shoot. Uh, can I print name? I think I can print name. Let's do that. What happened to my view here? So the name of the random module is random. We rename this one here. Refactor, rename, run me, and then we'll print name here. We run this one here. We get random is the name in the random module. Main is the name of runme.py because this is the main file that we're running. And then we get the 42 out because it was not random. So the file that you run, so right when we call Python here, we say, hey, Python executable, please read this file, run this file. It sets name to main for this file because this is the main file being ran. If you import it, you get the name of the module. It's super weird. But essentially, you can put code in here if you don't want it to run when you import the module. A better practice is just don't put code in modules. Like, just have your functions or your classes. That's a perfect module. You don't need other stuff. But if you want to have other things that run, like if you're playing with it, these sort of things. So think of this example of this web search script here that would go out and send web requests to fake searches here. Notice they don't send it anymore. They used to actually send it to Google, but they got blocked for running their script too many times or something. Um, so
if prevents the main code from running which is our code.
yeah, yeah. So it prevents code from running when you import.
So unless you call a function or a class, you won't run it.
Yeah, if they've put it in if name is main, if they've guarded it. Yep. So if you're writing modules that have code, put it inside the if name is main. Or just don't put code in your modules. Right? Just have your functions or classes. That's better. Modules are fun. You can force them to reload. This is kind of a weird thing. I wouldn't worry about it right now. It's nothing we need to deal with here. And then packages are folders of modules. So a folder of a bunch of Python scripts is a package. So depending on how you want to organize your files, you can have packages that have modules here. So they have a game package. Inside of that is a sound package. It's a folder. A folder called game, a folder called sound with music effects and speech inside of here, and then a folder for graphics with models, textures, and terrain. It's just ways for us to organize our code, right? Having just 100 different Python scripts in a folder, it's kind of messy, right? If we can break them up into more logical groupings here, we can put them in packages. It's just a way to group them together. Uh, and then you can import groups at a time if you want.
These packages are pretty much files.
I'm sorry?
These packages are pretty much folders with files.
Folders with files. Yep. Yeah. So it's just a way to organize them here. So you might have, sure, here's buildings. You can have a barn, have a house, have a man and a cow. Sure, why not? Like you can do all sorts of silly things if you want. You can import the top level package, or you can import lower level packages, right? Just with your dot notation, right? Depending on how you want to organize them here. You might have just the draw from ASCII art figures cow. Sure. Or if you just import ASCII art, you can just import ASCII art, and then everything gets the dot notation, right? Uh, the Python standard library has a bunch of stuff that we've already used before, right? We've used random, date, time, copy, these sorts of things, right? You can import them. Date and time is fun. Turns out dates and times are some of the hardest problems to solve in programming. believe it or not. Like time zones and then daylight saving time. It's gonna bother me now that I know I did it wrong. Um, those are really awkward to calculate. You'd think like, hey, how many hours ago was it? I could just say, what time is it now? What time was it then? But if I don't account for that twice a year daylight saving time, my program could be off. And it turns out if you're doing things like medicine administration, where you're supposed to give someone medicine every 4 hours, giving someone medicine 3 hours apart instead of 4 hours apart could kill them. That's a bad thing, right? Or 5 hours apart instead of four, and now they're in pain and upset at you. It's a bad thing, right? So dates and times are hard. They're really hard. So there's libraries that we use so we don't have to do this stuff by hand, right? You don't need to figure this out. Don't write it from scratch. There's a couple good rules of thumb in programming. One is don't write your own cryptography. Don't write your own cryptography for doing secure stuff. We've got people who've studied math and have PhDs in this sort of thing researching in the field. Use the stuff they've looked at and said it's good, right? Don't write your own. You're not going to do better than those people, I promise. No offense. Or yes offense. Like you just won't, right? If you want to, go get a PhD in applied mathematics, right? Go study cryptography, go research in that field and go do it. But your average software engineer should not write their own cryptography. Right? Our little like encryption scheme, it was not encryption. Like it's a cipher. Like it was, I felt bad calling it encryption, but whatever. Okay, those sorts of things. We're not going to solve those problems. So date and time, don't do it yourself. Use the library. That's another. Don't reinvent the wheel here. Use the library where smart people and teams of people have looked at these things and make sure they do the right things in all of those weird cases with daylight saving time and when you have leap year, like leap years screw things up too in your calculations. You're like, how many days was 3 years ago? 365 times three. Well, no, it's not because leap year, like sort of thing just sucks. So use the modules. They're fantastic. And they solve all those problems for you here. All right. Awesome. So a couple module labs here. Just have you like use the different things here. These are pretty easy, pretty straightforward. Uh, yeah, we're about out of time. Perfect. We did pretty good. So we don't actually have much to talk about on Wednesday, uh, which is okay because we got through this pretty quick. So we'll have more time to work on the project then. Come on. So that's due next Wednesday, right? We pushed it back a day. Do you want to talk about the project? How's that going for you with our classes and our testing? Yeah, and it's not in Zybooks. Sorry, it's the right way to test stuff though with unit tests. So focus on the classes first, and we can talk more about unit tests maybe on Wednesday. Might be a good time to do that here, right? Because testing them is 5 year points here, making sure that hey, I can add something to my shopping cart and then it shows up on the receipt for just my item class, right? My string comes out right. My total price comes out right. If something costs $1.50 and or I'm sorry, if I have three of them and it costs $1.50, I should get back $4.50 for total price, right? Those like, here's what I expect to get back out. Let's call the code. Did I get what I expected? Then arrange, act, and assert. So we'll spend some more time doing that on Wednesday, looking at these things here. That's all we're doing. So instead of printing it out to the screen and having us look at it, we'll tell Python to check it for us because it's better at that, right? And any code worth writing is worth testing. I promise you. Where are those like SDR? Where are these? Those are part of the Python built-in modules, right? The built-in standard library. I don't remember which one has the conversions. It's one of them. I don't remember where it is, but it's in those somewhere. I think when it crashed, it told us, right? It was in. Hang on, we did that. Let's print int of 10. Okay, ran that in debug mode. Step into email literal. Step into. I gave you the file before, didn't it? Like opened up another file. Oh yeah. I don't know if that's it. Kind of. Hang on. I forget where it is. I can find it for you later. I think it's conversions or something. Conversions. Versions. Module. Get in here. Units. I don't know. I'll find it for you later. It's somewhere in here. It opened it for us, right? It's time. Didn't it do it? It did it in the other project. Oh, it's fine. It's somewhere in there. Yep. All right. So I'll see you guys for lab in about 20 minutes. We'll practice exceptions. We'll make things that raise exceptions instead of just returning true or false or those sorts of things. We have to deal with it. It should be pretty quick.